Regardless of how I actually felt about it, Universal Arithmetic was first published in Latin and later translated into English, and remains to this day one of only 3 major works I wrote. In it are some of my particularly noteworthy contributions to the field of mathematics, including my work on developing a generalized binomial theorem, and work on infinite series.
At some point I also calculated pi to 15 digits accurately, just because I felt like I had nothing better to do.
Moving on, even more notable than my mathematical achievements is my total recreation of the study of physics. Both of the other 2 books I published were focused in the field of physics, although interestingly these 2 books varied greatly in style and approach to the subject. These books are the earlier mentioned Optics and my tremendously famous Philosophia Naturalis Principia Mathematica, usually shortened to just Principia. Published in 1686, it has been said that this book is a turning point in scientific history.
Speaking of the Principia, don't you find it odd that so many people just glaze over the part I'm most interested in, the generals column? While I didn't include it in the first edition, it did appear in the second, and I see no reason it hasn't gotten its proper due in popular culture. It has been said that it can be seen as my, and I quote, clearest and boldest expression of his religious faith. Now that sounds pretty important to me, but all people tend to remember is that ridiculous story of an apple falling from a tree.
Sigh. The Principia begins with a series of definitions that lay the groundwork for all later developments in the book. Compared to the usual practices of the day, there are no wasted words. Everything is there for a specific purpose in a decidedly organized fashion. In it I also discuss my concepts of space and time,
which would later be proven to be totally inaccurate, ironically by the real-life version of my current avatar.
As I was saying, I discussed space and time working with the Cartesian geometry that had recently been established. It was also in the Principia that I state my now famous 3 laws of motion that continue to haunt new physics students to this very day. The majority of the work is actually taken up with explorations of different kinds of motions of bodies in space. Most of my propositions are proved through extensive use of classic Euclidean geometry, with almost no algebra or calculus.
Pretty ridiculous for the inventor of calculus, wouldn't you say?
As if it wasn't enough to have totally revolutionized all of physics, I then proceeded to do groundbreaking work in optics. I conclusively demonstrated that a prism could split white light into all of the colors of the rainbow. I then further proved that these colors were of a fundamental nature, by showing that they could not be further altered by reflection or scattering. Working further in the optics, I invented my own version of the telescope, a vast improvement on the previous models. It is known in modern times either as a reflecting telescope or as a Newtonian telescope. Interest by the Royal Society on this telescope eventually led to publishing of the book, Optics, or its less catchy title, a treatise of the reflections, refractions, inflections, and colors of light, containing many brilliant observations about the nature of light that remain true to this very day.
Also containing a damn lot of rambling and random tangents. Optics was at least as much in my domain as in Newton one's. It is so far removed from the incredibly ordered system of Principia as to seem to have been written by an entirely different person. In it I go off on wild tangents, describing in excruciating details parts of my experiments, and in general just not writing particularly well. While the Principia was structured and organized to the point of tedium, this lovely book is written almost as a stream of consciousness. Also, some of my experiments involved sticking freaking needles into my eyes. How effing rational does that sound?